All right, so we're back into annuities, and what we're going to look at now is borrowing money. This is definitely something that has more than a few real-life applications. And so, again, because it's a little bit different with annuities, because you either have annuities where you're making regular payments to invest, that's what we just did earlier, or this time we're making regular payments to pay off a loan, borrowing. And so there is a different formula, a lot of the same variables. So we do have our R, our big R, I should say. That's the regular payments that you're making, but this time to pay off a loan. R is still our interest rate, which we have to adjust depending on how it's compounded. But now we have a couple of one variable that's the same, but it's not the same, and that is our N value. And what N is all about is the number of payments you have left. All right. So and now we're unfortunately not going to be able to go in depth with this, but you can actually figure out if I have a 10-year loan and you get through 5 years and say you win the lottery, you can figure out how much you need to pay off, or you could just pay off right there instead of having that loan extend for 5 more years. Now, in real life, the banks charge you cancellation fees and all that kind of stuff. Now, the other thing is PV. And so instead of the future value, which we had for annuities when you're investing, we have the present value, which means how much are you going to owe on this loan after a certain amount of time, depending on how many payments you've made. All right, so let's get to a few examples. All right, so example number 1. So again, I'm just going to read right off my sheet here. If Salman can afford to make a car payment of $400 a month, what is the most expensive car he can buy if the car loan is financed over 5 years at a rate of 7% compounded monthly? So here's a situation a lot of people don't realize, that when you're going to buy a car, you don't go look for the car first. That's not what you do. You figure out how much money you have and figure out how much you can afford, what kind of a car, or where your price range is before you ever look at a car. And so this person here has come up with the fact that they can afford to pay $400 a month. All right, so that's the regular payment that they are able to make. What we're going to find out is what is the most expensive car they can actually buy, or how much money can they borrow because they are able to pay off $400 a month. Now, again, we have to figure out our R value and our N value. Now, again, your interest rate, this question says that he's going to finance this over 5 years, and the interest rate is 7% compounded monthly. So we're making monthly payments here. So again, with our interest rate, I got to convert that percent to to decimal first. So again, 7% divided by 100% is 0.07. But because we need to convert it to a monthly rate, I have to cut it into 12 pieces. And so I'm going to get another 0 there for sure. And again, the two first non-zero numbers, 0.0058 is our monthly interest rate. All right, now the number of payments left. Well, if this person is just borrowing the money now, they're going to have to make all those payments. So they are looking at 5 years worth of payments. And each of those years, because they are making monthly payments, there's 12 of them. And so 5 times 12 is 60 total payments are left at the beginning of the loan. That's what we're looking at here when they just started paying off the loan. All right, now that is actually, a car loan is typically 5 or 6 years, because you would not want a 10-year loan on your car, because if it breaks after 7 years, you're still making payments on a car that's crushed, right? So typically a car loan is 5 or 6 years. All right, so in this case, we have all our values that we got 3 out of 4, which you need. And so we're going to find out what is the most expensive car that this person is able to afford. All right, where am I going to put this? All right, so present value of our loan. Again, our interest, or our monthly payments, they can make $400 worth of payments. Again, we have square brackets because I have brackets within brackets. I'm going to run out of room here, I think. All right, so I'm going to have 1 minus. Then I have the 1 plus R. So again, my R is 0.0058. So I'm going to have a 1.0058 to the power of let's get a little smushed here, to the power of 60. No, not to the power of 60. This is a common mistake. It's a negative exponent, so it's a minus 60 there. All right, and again, typically what can happen is people forget the little r down at the bottom, which is just the r, not 1 plus the r, and so it would be 0.0058. All right, now, just like this morning, I'm going to use bedness. So I'm right to the brackets, right? So I have to do this 1.0058 to the power of negative 60. All right, so I'm going to have 400 here. Then I've got 1 minus, and I take that 1.0058 to the power of 60, and negative 60. All right, so I take 1.0058 to the power of negative 60. And I get 0.7068. I like to go with 4 decimal places when we're doing financial math because we're working with percentages. All right, and again, I'm going to divide that by my 0.0058. All right, and so let's see, the loan, again, going with the brackets here, so I got 400. 1 minus 0.7068, I'm getting 0.2932. And again, of course, divided by 0.0058. All right, and then now I can just figure this all out in one step. 400 times the 0.2932, and then lastly divided by the 0.0058. And if you're willing to pay $400 or can pay $400 a month for a car, at a interest rate of 7% compounded monthly, the best or most expensive car we're looking at here is $20,220.69. All right, so again, when you're going to look for a car, it's a waste of time unless you know what you can actually afford. So in this case, this person here can afford $700. 7% right now is a standard interest rate for a car loan. I know that because I just bought a car last year. And so in this case, that's all you can afford. Or not all you can afford, but you can afford a $20,000 car roughly. All right, now, example 2, we're going to move on to houses. Condos. Keep my formula there because, again, you got a formula sheet to use for the test. I'm not asking you to memorize these things. I wouldn't in school either. Big, complicated formulas. Let's make sure my R is nice here. All right, so now we get to, whoa, that's still wet. Example 2, where we're looking at buying a house. All right, so in example 2, if a family, because again, we're going to borrow money here, so I'm going to break down my variables here. PV, I got my R, my interest rate, and of course, N, which is the number of payments I got to make here. So, or how many payments I have left. So in example 2, if the family purchases a home for $400,000 at a rate of 5.7% compounded monthly again, over a period of 25 years, find the family's monthly payment. All right, so they are looking this time. We know how much the house is worth. We want to know what the mortgage payment is going to be. All right, so the house is worth $400,000. So that's how much you would have to borrow. All right, now, what is the monthly payment? We don't know. That's our R, our regular payment. And now, again, we get to the rate, the interest rate. It is 5.7% compounded monthly. So again, I'm going to convert that to a monthly interest rate. So first I convert the percentage to a decimal, and then again, because it's monthly, I got to divide it by 12 to cut it into 12 parts. And I end up with 0.0048. All right, now, and the number of payments left. A typical home loan is 25 years. Now, because you're making monthly payments, you've got 25 years, you're going to make 12 payments per year. And so that 25 times 12 would give us 300 payments. A lot of payments to make over a 25-year span. But this time we're going to find out what our mortgage payment would actually be. All right, so I'm going to substitute in my values here. So I have a 400,000 is our present value because that's what we presently own. I'm going to move this down a bit. I'm going to run into that formula again here. I'm going to give myself some space here. So 400,000. All right, equals, we don't know what the regular payment's going to be. Again, we got the square brackets. So I got 1 minus 1 plus the rate. So there's the rate. So I'm going to have 1.0048, but this time to the power of negative 300. And of course, I can't forget my rate down below, which is just the rate, not 1 plus the rate. Okay, well, as I've done before and did earlier today, going with the brackets, figuring out what we got. So I got 400,000 again on this left side. It's just going to be sitting there for a bit. All right, and then in brackets here, I got to figure out what 1.0048 to the power of negative 300. Again, a lot of mistakes I see in this formula is forgetting that minus sign, which will really throw your answers out of whack. And so I get 0.2377. All right, and again, divided by 0.0048. All right, so again, simplifying here in the brackets. So I get 400,000 equals R, and I got 1 minus 0.23. Let's see here. So I'm going to get 0.7623. All right. It's in the brackets. Figure that out. Again, I have down here 0.0048. And as I mentioned earlier this morning, here's the most common place I just see students get stuck. To be honest with you, they don't get it wrong. They get stuck. I'm just going to combine these two numbers. So I'm going to take my 0.7623 and divide it by that 0.0048. And so that number, you're going to take a decimal divided by a much smaller decimal. I get 158.8. There we go. All right, and then lastly, dividing by my numerical coefficient here. And so that's the number in front, or in this case, behind our variable. It's multiplying it. So I take my 158.8, divide the two of them. It's two sides. All right, so they divide each other out. And the regular payment that we would have to make for a $400,000 house at 5.7% compounded monthly is $2,518.89. So a lot of money. $2,500 and change. Huh, not really change, but seems like it when you're spending that much money. And there we go. Now, example 3. Change it up a little bit, but not much. If you look at example 3, I am now going to purchase a home for $400,000, right? So it's the same house, but here's what's going to change. It's still going to be over 25 years, but all that's going to change is the interest rate. All right, so I'm going to redo this. All right, so we have the same house. All right, I'm going to leave this. This is our answer right here from 5.7%. So all that's changed here is our interest rate. And this happens when you have a home loan. Here's the trick that you don't learn until you get older and you actually buy a house, is that your interest rate changes every 5 years. Most of the time. Again, it's real life stuff, but for most people, your interest rate is going to change every 5 years. You don't have a choice on this. Sometimes it goes lower, sometimes it goes higher. So this person, same house, but now our interest rate has been changed to, whoops, not interest rate, but our it's been changed to 12%, still compounded monthly. All right, so again, I take my rate divided by 100%, so I get 0.12. Whoops, get a little wet there. All right, so we get the 0.12. And again, because it's a monthly interest rate, I got to divide it by 12. And so I take that, 0.12 divided by 12, I get 0.01. All right, there we go. So everything's the same. All that's changed in this situation is the interest rate. All right, so again, I'm going to do the same thing. I'm going to sub in my values here. So my present value, same house, 400 grand. Your regular payments, well, we're going to change that. And square brackets, I have 1 minus 1 plus r, which in this case is just 1 plus this, so 1.01. And again, it's to the power of negative 300. And of course, common mistake, can't forget my interest rate down here of 0.01. Monthly interest rate, I should say. All right, well, again, bad miss, going to the brackets here. So we get 400,000 equals, we got R, let's see here. Then I got to take 1 minus 1.01 to the power of negative 300 here. So I get my calculator out here. 1.01 to the power of negative 300. And I'm getting 0.0505. Fair enough. And then again, down below here, our 0.01. All right, so continuing on with our brackets here. So I got 400,000 equals, time for a new pen, equals R times 1 minus 0.0505. It's going to be like 0.9495. And of course, 0.01. All right, so again, just like last time here, I'm going to combine these two numbers, right? That's where I always say students get stuck. All right, so I have R, and let's see here. I take that 0.9495, I divide it by 0.01. I think I'm just going to get 94 something. It is 94.95. All right, now my last step, I'm going to divide by my numerical coefficient here. So I'm going to divide both sides by 94.95. And my regular monthly payment that I would have to make here is now, check this out, $4,212.74. So again, that was the same house paid over the same amount of time, but because of the interest rate going from 5.7% to 12%, your regular payments have jumped quite a bit. And what I'm trying to show you there is that when you have a loan, it's not just how much you're borrowing that matters, it's the interest rate that matters. Because the higher the interest rate, again, interest, when you're borrowing money, you're paying basically a tax for borrowing. The higher the interest rate, the more you're going to have to pay off in that loan. So again, when you're borrowing, when you're looking for a car or a house, whenever that happens, it's key to shop around to different banks. A lot of them are very close, but again, you want to make sure that you get the lowest interest rate possible, which obviously will have a big difference, or can have a big difference, in your monthly payments. All right, so that is it for our financial applications unit. All right, so give me a second here.